Hello everyone. Here we are deriving one-dimensional heat equation, that is dou u by dou t is equal to c square times dou square u by dou x square. Before the derivation, we should know the empirical laws of heat flow that we are studied in thermodynamics. Okay, the first empirical law says that heat always flows from higher temperature to the lower temperature. Heat always flows from higher temperature to lower temperature. The second law, which is the amount of heat stored in the body, amount of heat stored in the body is always proportional to amount or quantity of heat proportional to its mass and temperature. Amount of heat or quantity of heat stored in the body is proportional to mass and temperature. And the third law, the rate of heat flow across an area, which is proportional to area and to the temperature gradient, that you can write it as dy by dx if it is one dimension. Okay, only one variable, temperature gradient normal to the area. Okay, so the rate of heat flow across an area is always proportional to the area and the temperature gradient, which is normal to the area. Next, let us consider a homogeneous bar of uniform cross-sectional area alpha square units. Assume that the sides are insulated, that means covered by heat resistance material. Okay, insulated by using heat resistant materials, so that the streamlines of heat flow always parallel and perpendicular to the area alpha. Okay, so first we have taken a bar, okay, uniform cross-sectional bar, homogeneous bar, and this area, cross-sectional area, is alpha, and the sides of this bar is insulated so that the streamlines of heat flow always parallel and perpendicular to the area. Okay, parallel and perpendicular to this area. Take one end of the bar as origin. Okay, and the direction of heat flow always in the positive x-axis. Next, let us take a small portion, this portion of this bar, element of this bar, okay, of thickness delta x, and this distance is x, this distance is the x plus delta x. So the thickness of this small element of the bar is delta x, and this r1 indicates the rate of heat flow, inflow, okay, and r2 or ro you can denote by ro also, outflow heat. Okay, next, here let us take rho be the density, S be the specific heat, and K be the thermal conductivity of the material. Okay, thermal conductivity of this bar. Next, let U of x comma t be the temperature at a distance x from the origin O. Okay, U of x comma t be the temperature at a distance x. Okay, at a distance x from the origin. Okay, and delta U be the change in temperature or temperature change of this slab of thickness delta x. Okay, delta U be the change in temperature. The quantity of heat stored in the body or heat stored in this slab element is, as we seen here by using second law of thermodynamics, the amount of heat or quantity of heat stored in the body is proportional to its mass and temperature. So here the amount or quantity of heat in this slab element is proportional to density, correct? Since we know that mass is equal to Density is equal to mass by volume. So mass is equal to density into volume. So here density is rho into volume. So here rho volume is nothing but area times delta x, the thickness, right? Area times thickness into temperature, that is change in temperature, that is delta U. And this proportionality constant is taken as S, that's nothing but specific heat. That's why the quantity of heat stored in the slab is S rho alpha delta X, that's nothing but the mass of this element into delta U. Okay, delta U is the change in temperature. Hence, rate of increase of heat or rate of change of heat in this slab is nothing but rate inflow minus rate R flow, right? Ri means inflow of heat and Ro means outflow of heat. The difference between Ri minus Ro gives the rate of change or rate of increase of heat. So that's nothing but differentiate this with respect to T, quantity of heat divided by time gives the rate of change in the heat. So it is S rho alpha delta X times dou U by dou T while differentiating with respect to T, right? Dou U by dou T. Next, Ri means, it is inflow of heat, that is rate according to the third law of thermodynamics or third empirical law. Rate of heat flow across an area is proportional to area and temperature gradient. So it is Ri is proportional to area is alpha times the temperature gradient is dou U by dou X at the point X. Similarly, Ro is proportional to area and temperature gradient is dou U by dou X at the point X plus delta X, right? And proportionality constant is K with a negative sign, since always heat flows from higher temperature to lower temperature. That's why negative sign is used. The proportionality constant is taken as K, right? That is thermal conductivity of the material. Hence, rate of increase of heat, this value S rho alpha delta X dou U by dou T is equal to here difference between Ri and Ro. So here Ro is the second quantity, but which is negative into negative becomes positive, and K and A are common term, we can take out. So K is common and Ri is the negative value. So I will write as the second term dou U by dou X at the point X plus delta X minus dou U by dou X at the point X, right? The difference between Ri minus Ro. Next, dividing by this quantity. Before that, you can cancel out alpha, and dou U by dou T is equal to K divided by S times rho into dou U by dou X at the point X plus delta X minus dou U by dou X at the point X divided by delta X. And let us take this K divided by S rho as some constant. All the three values are constant, that is C square. This constant is called as diffusivity of the substance. Okay, and taking limit delta X tends to 0. I mean the thickness of this small element of this bar is very small, right? Then this K divided by S rho, we are taken it as C square. It is dou U by dou T, dou U by dou X at the point X plus delta X minus dou U by dou X at the point X divided by delta X. This gives, by using the limit definition of differentiation, here partial differentiation, this value is nothing but dou by dou X of differentiation of dou U by dou X partially with respect to X. Or you can write dou U by dou T is equal to C square times dou square U by dou X square. Okay. And this is called a one-dimensional heat flow equation, or simply a heat equation. Or you can write this equation as ut is equal to c square uxx.